Hello everybody, welcome to my Digital India with Ravindra DASTIKOP series. Today we will be talking about digital twins. Digital twins is regarded one of the top trending technology which is going to shape our business and society. And in today's discussion we will be talking about its origin, introduction, uses and vendors and benefits. The agenda for today's presentation is introduction, what is a digital twin, some definitions about digital twin, working of digital twin use cases, means where are they applied, digital twin benefits. Introduction. Digital twins are virtual replicas of physical devices that data scientists and IT pros can use to run simulations before actual devices are built and deployed. They are also changing how technologies such as IoT, artificial intelligence and analytics are optimized. Digital twin technology has moved beyond manufacturing and into merging worlds of Internet of Things, artificial intelligence and data analytics. As more complex things become connected with the ability to produce data, having a digital equivalent gives data scientists and other IT professionals the ability to optimize deployments for peak efficiency and create other what-if scenarios. Now let us understand what is a digital twin. A digital twin is a digital representation of a physical object or a system. The technology behind digital twins has expanded to include large items such as buildings, factories and even cities, and some have said people and processes can have digital twins, expanding the concept of this even further. The idea first arose at NASA. Full-scale mock-ups of early space capsules used on the ground to mirror and diagnose problems in orbit eventually gave way to fully digital simulations. However, the term digital twin really took off after Gartner named digital twin as one of the top strategic technologies trends in 2017, saying that within 3 to 5 years, billions of things will be represented by digital twins, a dynamic software model of physical things or systems. A year later, Gartner once again named digital twin as the top trend, saying that with an estimated 21 billion connected sensors and endpoints by 2020, digital twins will exist for billions of things in the near future. In essence, a digital twin is a computer program that takes real-world data about a physical object or a system as inputs and produces as outputs predictions or simulation of how that physical object or system will be affected by those inputs. Now that we have a broad idea of what is a digital twin, a program which actually simulates a physical thing or a system, now let us look into some definitions. Definition number 1. The digital twin is a set of virtual information constructs that fully describes a potential or actual physical manufactured product from the microatomic level to the macro geometrical level. At its optimum, any information that could be obtained from inspecting a physical manufactured product can be obtained from its digital twin. Definition number 2. A digital twin is an integrated multi-physics, multi-scale probabilistic simulation of an as-built vehicle or system that uses the best available physical models, sensor updates, fleet history, etc. to mirror the life of its corresponding flying twin. Definition number 3. A digital twin is using a digital copy of the physical system to perform real-time optimization. Now let us look into the process of how a digital twin is made to work. A digital twin begins its life being built by specialists, often experts in data science or applied mathematics. These developers research the physics that underlie the physical object or a system being mimicked and use that data to develop a mathematical model that simulates the real world original in the digital space. The twin is constructed so that it can receive input from sensors gathering data from a real-world counterpart. This allows twin to simulate the physical object in real time, in the process offering insights into performance and potential problems. The twin could also be designed based on a prototype of its physical counterpart, in which case the twin can provide feedback as the product is refined. A twin could even serve as a prototype itself before any physical version is built. The process of developing a digital twin is outlined by a company that creates digital twins of the massive container ships that carry much of the world commerce, an extremely complex kind of digital twin application. However, a digital twin can be as complicated or as simple as you like, and the amount of data you use to build and update it will determine how precisely you are simulating a physical object. Now let us look into the digital twin use cases. The cargo vessel, which was mentioned earlier, gives you a sense of potential use cases. Objects such as aircraft engines, trains, offshore platforms, and turbines can be designed and tested digitally before being physically produced. These digital twins could also be used to help with maintenance operations. For example, technicians could use a digital twin to test that a proposed fix for a piece of equipment works before applying fix to the physical twin. Digital twin business applications are found in number of sectors. Digital twins in energy sector. The energy sector, GE has used twin technology to create what it calls digital wind farm, a cloud-based model of wind farm. According to General Manager for Wind Products, every wind farm has a unique profile like DNA or a fingerprint. We thought if we could capture data from the machines about how they interact with the landscape and the wind, we can build a digital twin for each wind farm inside a computer, use it to design the most efficient turbine for each pad on the farm, and then keep optimizing the whole thing. What this means in practice is, thanks to digital twin technology, engineers can mix and match different turbine configurations according to the conditions on the wind farm. Then, once the wind turbine is installed, the digital twin model can collect and analyze data from the real life version and suggest ways to make it even more efficient. And another area where digital twins are finding application is manufacturing. Manufacturing is the area where rollouts of digital twins are probably the furthest along, with factories already using digital twins to simulate their processes, as mentioned from a case study by Deloitte. Hospitality is another sector where digital twins are being used. Digital twin technology can be used to simulate real life events and situations, and this could play a major role in the hospitality industry in future. As an example, CKE Restaurants Holdings has been using digital twin technology to increase productivity of its Carl's Jr. and Hardy restaurants. Restaurant floors and kitchens were digitized, allowing the company to test different configurations that would help to reduce employee traffic and improve the environment for the customers. Another interesting area where digital twins can be used is city management. City management, if you can have a digital twins of a wind farm or restaurant, why not an entire city? Digital twin technology helps city planners understand improve factors like energy consumptions. There is already a digital twin of Singapore, and we can expect other cities to follow this suit in future. With smart cities being rolled out gradually everywhere in the world, digital twins of those cities might be also a useful thing. The automotive sector is also using digital twins. Automotive digital twins are made possible because cars are already fitted with telemetry sensors, but refining the technology will become more important as more autonomous vehicles hit the roads in coming days. Retail environment is also finding application for digital twins. The digital twin is still relatively a new concept in retail, but it could prove very valuable, particularly when it comes to modeling customer behavior in stores. Analytics company is highlighting digital twin technology as part of what it calls Retail 4.0, an approach that gathers granular real-time data from physical retail environments and uses that data to improve awareness of customer activity and behavior. Healthcare sector also uses digital twin, but they are very special in its application. Healthcare is the sector that produces digital twins of people. Band-aid sized sensors send health information back to a digital twin used to monitor and predict a patient's well-being. Digital twins and IoT. Clearly, the explosion of IoT sensors are part of what makes digital twins possible. And as IoT devices are refined, digital twin scenarios can include smaller and less complex objects, giving additional benefits to companies. Digital twins can be used to predict different outcomes based on variable data. This is similar to run the simulation scenario often seen in science sci-fi films. where a possible scenario is proven within digital environment. With additional software and data analytics, digital twins can often optimize an IoT development for maximum efficiency, as well as help designers figure out where things should go wrong and how they operate before they are physically deployed. The more that a digital twin can duplicate the physical object, the more likely that efficiencies and other benefits can be found. For instance, in manufacturing, where more highly instrumented devices are, the more accurately digital twins might simulate how the devices have performed over the time, which could help in predicting future performance and possible failures. Digital twin vendors. Building a digital twin is a complex, and there is as yet no standardized platform for doing so. Ian Scarrett, a consultant working in the field who has long history in open source behind him, has proposed an outline of digital twin platform, though this is a first step as it suits the rather embryonic nature of the space. In contrast, with many emerging technologies, commercial digital twin offerings are actually coming from some of the largest companies in the field. For instance, GE, which developed digital twin technology internally as part of its jet engine manufacturing process, is now offering its expertise to customers, as is Siemens, another industrial giant heavily involved in manufacturing. Not to be outdone by these factory floor suppliers, IBM is marketing digital twins as part of its IoT push, and Microsoft is offering its own digital twin platform under Azure umbrella. In a November 2017 article for Network World, contributor Deepak Puri outlined an example of an Oracle digital twin tool that provides users with two options, a digital twin and a predictive twin. The digital twin can include a description of the devices, a 3D rendering, and details on all the sensors in the device. It continuously generates sensor readings that simulate real life options. The predictive twin models that future state and behavior of devices. Puri writes, this is based on historical data from other devices which can simulate breakdowns and other situations that need attention. As a part of its digital twin initiative, Microsoft is taking the concept and applying it to processors in addition to physical products. In a white paper, Microsoft proposes the idea of the digital process twin. The process digital twin is the next level of digital transformation, compounding product digital twin benefits throughout the factory and supply chain, Microsoft states. The associated white paper highlights some advanced manufacturing scenarios that product digital twin don't support, but process digital twin would. Now that we have seen some cases, applications, now that we have seen different applications of digital twin in different industries, let us look at the benefits and the concerns. Digital twins have users and benefits. It is clearly illustrated by the cases already mentioned. But keep in mind that the Gartner warns that digital twins are not always called for and can unnecessarily increase complexity. Digital twins could be technology overkill for a particular business or a problem. There are also concerns about the cost, security, privacy, and integration aspects of digital twin implementation. Because of the reasons stated earlier and the kind of application it is finding, digital twin skills is in great demand. Interested in becoming a digital twin professional, the skill sets are demanding and require specialized expertise in machine learning, artificial intelligence, predictive analytics, and other data science capabilities. And this is a great career to consider. Now let us summarize. All indications seem to predict we are on the cusp of a digital twin technology explosion. More companies will learn of real world and pilot program success stories and will want to deploy their very own digital twins to gain a competitive advantage in business scenarios.